You're 34, standing at a bathroom mirror in 2026, and there it is. One single strand, catching the light wrong, standing up straighter than the rest. Not brown, not black, just gone. Colorless. You lean in closer, the way everyone does, like proximity will make it change its mind. It won't. That one hair has quietly stopped making pigment. Somewhere in your scalp, a tiny biological factory that's been running since before you could walk just clocked out for good. You didn't feel it happen. Nobody ever does. It just shows up one ordinary morning, uninvited, on a random Tuesday that otherwise had nothing special about it at all. So here's the actual question, and it sounds simple until you sit with it. Why does hair go gray at all? Because your aging is a cop-out answer. And you know it. Something extremely specific is happening inside a structure smaller than a grain of rice. It's happening over and over, millions of times, across your whole scalp. And it's running on a totally different schedule for every person on Earth. Some people are gray at 20, some are 70 with a full head of black hair, smug about it at every family reunion. That gap isn't random noise. It's the result of a half-dozen separate biological systems, genetic, chemical, neurological, all quietly converging on the same follicle. Gray hair isn't a switch flipping. It's a slow-motion collision, years in the making that you only notice the day it finishes. Everything you're about to learn was happening to you long before you saw the evidence in a mirror. And it's not one thing. It's never one thing. There's a stem cell story here, a genetic story, a chemistry story, and a stress story. All four turn out to be true at once, stacked like sediment in the same strand of hair. Some of what you've heard about gray hair is folklore dressed up as biology. Some of the real science is stranger than the folklore ever was. Let's go, starting with the part almost nobody actually gets right. Gray hair isn't a color. That's the first thing to get straight. There is no gray pigment, no silver dye your body quietly switches on one day. Gray and white hair simply has little or no pigment in it at all. You're seeing the natural pale, yellowish-white of the keratin protein itself, with the color subtracted out. Every hair grows out of a follicle, and living inside that follicle are cells called melanocytes. Think of them as tiny pigment factories, pumping granules of melanin into each strand as it grows, the same pigment that colors your skin and your eyes. Blonde, brown, black, red, it's all melanin. Just different types and amounts of it. When a follicle's melanocytes stop delivering pigment, the hair that grows out afterward comes out with nothing in it. Not less color, none at all. Here's the thing nobody tells you. Your hair doesn't fade like an old photograph left in the sun. It's built colorless from the root, strand by strand, the moment the factory goes quiet. That gray hair in your mirror isn't old hair losing its color, it's brand new hair that was never given any color to begin with. Slightly depressing once you think about it that way. It also means dyeing a gray strand doesn't fix anything at the source. You're painting over an empty factory, not restarting it, which is exactly why the color grows out again in a few weeks. The factory itself stayed shut the whole time, unimpressed by whatever shade you picked from the box. Onward to why it shuts in the first place. So why does the factory go quiet? This is where it gets genuinely strange. Melanocytes aren't permanent workers. They're serviced by a reserve of melanocyte stem cells tucked into a structure in the follicle called the bulge. That reserve is supposed to keep replenishing pigment-making cells for decades. In 2023, researchers publishing in the journal Nature described these stem cells as unusually flexible. They can shuttle back and forth between a dormant, immature state and an active, pigment-producing state, depending on what the follicle needs that week. Picture a small backup crew that can either rest in the break room or suit up on the factory floor, switching roles on demand for years. Here's the problem, according to that research. With age, more and more of these cells get stuck. They drift into the wrong compartment of the follicle and lose the ability to switch back into stem cell mode. They aren't dead, they're just stranded in the wrong room, permanently off duty. Multiply that across thousands of follicles over decades, and eventually a follicle runs its reserve down to zero. No stem cells left to convert, no melanocytes left to replace, no pigment left to deliver. That's not damage in the usual sense. That's retirement, whether the hair asked for it or not. And because every follicle on your head runs its own private countdown on its own timeline, graying never arrives as one dramatic event. It arrives as thousands of tiny, unrelated retirement parties scattered across your scalp over years, which is exactly why gray hair shows up strand by strand instead of all at once. Now, how much of this is simply written into you before you're even born? A lot, it turns out. In 2016, researchers at University College London studied genetic data from more than 6,000 people across Latin America, a mixed ancestry group spanning European, Native American, and African backgrounds. The study ran in the journal Nature Communications. They pinpointed a gene called IRF4, already known to help regulate how melanin gets stored and used, as the first gene ever directly linked to gray hair in humans. It's not the only gene involved. The researchers were careful to say IRF4 works alongside plenty of other factors nobody's identified yet. But it was proof that graying isn't purely a stopwatch ticking down. Some of it is inherited code, set decades before your first gray hair ever shows up. Here's a fact worth pausing on. You've probably heard the 50-50-50 rule. The old dermatology claimed that by age 50, half of all people have hair that's half gray. A 2012 survey in the British Journal of Dermatology tested that claim directly, examining more than 4,000 healthy volunteers around the world. The real number wasn't 50%. It landed somewhere between 6 and 23%, depending on ancestry, with people of Asian and African descent graying noticeably later than people of European descent. The tidy rule everyone repeats confidently at parties is nowhere close to true. Genetics doesn't run on one universal clock. It runs on your specific ancestry, ticking at its own private pace. That same 2012 survey also found men grayed noticeably faster than women across the entire sample, for reasons researchers still can't fully pin on any single gene. So if a friend swears their genetics skipped gray hair entirely at 60, they're not lying. They just happen to be sitting on a lucky roll of IRF4 and everything sitting quietly beside it. Somewhere in your own genome is a version of that same lottery ticket, already decided, just waiting for the calendar to catch up with it. Which raises an obvious worry. Does gray hair mean something's wrong with you? Mostly, no. For the vast majority of people, gray hair is simply age plus genetics doing exactly what age plus genetics do, with zero relation to underlying illness. But dermatology reviews do flag a smaller category called premature graying, hair turning gray well before the typical range for your ancestry, sometimes before 20. And that version can occasionally track with real, checkable conditions. Vitamin B12 deficiency shows up repeatedly in that research. So does an underactive or overactive thyroid. So notably does smoking, which several studies link to earlier than expected graying, likely through added oxidative stress on the follicle. None of this means one gray hair equals a diagnosis. It means premature and unusually rapid graying is sometimes worth mentioning to a doctor, the same way you'd mention any change your body wasn't supposed to make on its own schedule. Of that whole list, smoking is one of the few items you could actually control, unlike your ancestry or your birth year. For everyone else, the vast majority, this is just the ordinary biological weather of getting older. Nothing more sinister than that. Worth remembering next time someone tells you they're too stressed to have brown hair anymore, as if it's a medical fact. Here's a chapter that sounds too strange to be real, but it's backed by lab data. Your hair is quietly bleaching itself from the inside, using a chemical you'd recognize from a salon shelf. In 2009, a team publishing in the FACB journal found that aging hair follicles slowly accumulate hydrogen peroxide. Yes, the same compound used in peroxide hair dye. Normally, an enzyme called catalase breaks that hydrogen peroxide down into harmless water and oxygen before it can do any damage. But catalase levels drop as you age, and a set of repair enzymes that usually patch up the resulting damage decline right alongside it. The result is a slow chemical buildup at the root that blocks another enzyme called tyrosinase, the exact enzyme melanocytes need to actually manufacture pigment. One researcher on the study put it almost too simply. Every hair cell makes a tiny bit of hydrogen peroxide its whole life, but as you get older, that tiny bit becomes a lot. It's a slow leak turning into a flood, decade by decade, the kind of leak nobody notices until the basement's already full. Your body isn't just failing to add color anymore at that point. It's actively working against its own pigment factory, using peroxide it manufactured itself, no salon required. And no, standing near a swimming pool won't speed any of this up, however tempting that theory is at the community pool. This entire process happens inside the follicle, nowhere near the water, nowhere near a bottle, nowhere you could ever reach with a bathroom cabinet's worth of products. It's a strange kind of symmetry. The same molecule hairdressers pour on deliberately to strip color from dark hair is quietly being generated by your own scalp. In tiny amounts, for free, whether you asked for it or not. Let's be honest about a few things people believe with total confidence, and probably shouldn't. First, plucking one gray hair does not make two grow back in its place. That idea has been repeated for generations, and it simply isn't how follicles work. Each hair grows from its own separate independent unit. There's no shared root system under your scalp connecting one follicle to its neighbor, and no wiring that lets pulling one hair trigger cell growth in another. What repeated plucking actually risks is scarring or damaging that one follicle over time, meaning fewer hairs there eventually, not more. Second, and this one runs deeper into folklore, the idea that hair can turn white overnight from shock, immortalized by the legend that Marie Antoinette's hair went white the night before her execution in 1793. It's a wonderful story. It is not biologically possible. Hair that's already grown out of the follicle is dead protein, keratin, and dead protein cannot change color once it exists outside your skin, the same way a shirt can't re-dye itself while you're still wearing it. What likely explains cases like this is a sudden, aggressive form of hair loss called alopecia areata, which can shed pigmented hairs faster than the gray ones nearby. So within days, not hours, a person's remaining hair looks far grayer, simply because the colored strands vanished first. It's an illusion built from real hair loss, not sudden pigment loss. Good story, wrong mechanism. Now for the stress question, because you've definitely heard this one, and the honest answer is more interesting than the meme version. Stress genuinely can cause gray hair. That part is real, confirmed in a landmark 2020 study out of Harvard, published in Nature. Researchers led by Yachie Su exposed mice to different kinds of stress. Mild pain, physical restraint, psychological pressure. They traced the effect to a neurotransmitter called norepinephrine, released by the sympathetic nervous system directly onto the melanocyte stem cells living in the follicle. That flood of norepinephrine forced nearly the entire reserve of dormant stem cells to activate and migrate away all at once. Picture an alarm going off and emptying an entire office building in a single stampede, instead of everyone leaving gradually across a normal workday. Within just a few days, the researchers found all the melanocyte stem cells in the affected follicles were gone. Not resting. Gone permanently from that follicle. So the mechanism is real, and the neuroscience checks out, and it happens shockingly fast at the cellular level. What it does not do is turn a full head of hair white in one bad night. That stampede still has to work through the ordinary pace of hair growth. One strand and one follicle at a time. So the next time someone jokes that their toddler gave them gray hair by Tuesday, they're not entirely wrong about the biology, just badly wrong about the timeline. Interestingly, the same Harvard team also noted this norepinephrine pathway is completely separate from the classic stress hormone, cortisol, the one most people blame by default. Your nervous system, not your hormones, is the one signing off on this particular decision. It's a small but telling distinction because it means the old advice to just relax and stop worrying was aimed at roughly the wrong department of your own body the entire time. There's one last thing saved for the end, and it's the wildest part of this whole story. Everything up to now makes graying sound permanent, a one-way door with the stem cells gone and the pigment gone for good. But in 2021, researchers at Columbia University, led by Martin Picard with lead author Eilert Rosenberg, published a study in the journal eLife that overturned that assumption. Rosenberg developed a technique to scan individual human hairs in slices roughly 1/20th of a millimeter thick, with each sliver representing about 1 hour of growth. It's essentially reading a single strand like tree rings, except the rings track pigment instead of wood. Working with 14 volunteers who kept detailed stress diaries, the team matched color shifts along each hair to real stress events in that person's actual life. And they found something remarkable. Individual hairs didn't only gray during stressful stretches. In at least one case, 5 hairs from a single participant reverted back to their original dark color during a period of stress relief. An actual vacation. Analysis of roughly 300 proteins shifting during these color transitions pointed to changes in mitochondria, the cell's energy centers, rather than the permanent stem cell death seen in the earlier mouse study. Think about that for a second. Some gray hair isn't a closed door at all. It's a dimmer switch tied to your nervous system in real time, capable of flickering back on. And that's not a metaphor. That's measured, published, peer-reviewed data. There is a real limit, though. The window for reversal seems to close the longer a hair has stayed fully gray. So this isn't a promise that a calm year will undo decades of pigment loss. But for a while at least, the color of your hair is being negotiated in both directions, not just quietly lost. It also means that gray hair, in its early stages, might be less like a tombstone. It's more like a mood ring for your nervous system. It quietly logs the year you had, one strand at a time, whether you were paying attention or not. You're not the only creature this happens to either, if that's any comfort standing at that mirror. Chimpanzees gray with age much like people do, though researchers studying wild chimps found gray muzzle hair isn't even a reliable way to guess an individual's actual age. Mountain gorillas take it further. Dominant older males, the ones called silverbacks, grow a genuine silver saddle of hair across their backs around age 12. Unlike almost anything in humans, that graying actually functions as a visible signal of status and maturity inside the group. Dogs commonly gray too, and some veterinary researchers have linked earlier graying in dogs to a more anxious temperament. Cats, strangely, mostly don't show it the same way. A difference in coat biology scientists still haven't fully nailed down, much to the smug satisfaction of every cat on Earth. Across most of the animal kingdom, gray hair looks less like a purpose. It looks more like exactly what it is in you: stem cells slowly running down. Mostly that happens after the years that mattered most for survival and reproduction have already passed. Humans are simply one of the few species that live long enough and stare in mirrors often enough to actually notice it happening in real time. Wild animals, for the most part, rarely survive long past their reproductive peak, so there's been little evolutionary pressure to keep a follicle's stem cell reserve topped up for decades afterward. Humans broke that deal by living so much longer than most of our biology was originally built for, and gray hair is one of the quieter bills that comes due. It's a strangely humbling thought. The same modern medicine, sanitation, and safety nets that let you live long enough to read this sentence are also the reason you'll eventually watch your own hairline turn a color. Evolution never really planned for. So picture your ancient ancestors for a second, crouched around a fire tens of thousands of years before mirrors ever existed. The elders of the group were easy to pick out, pale hair catching the firelight from across the camp. They had no idea about melanocytes or norepinephrine or hydrogen peroxide quietly building inside a follicle. They just knew gray hair meant someone who had survived long enough to know things: where the water was, which berries would kill you, how to get a family through a hard winter twice in a row. Somewhere in that firelit circle is the exact same biology sitting on your head right now. Stem cells, genes, chemistry, stress, all still running the same ancient program, unbothered by the fact that you now understand it. You can name the gene, cite the year, explain the enzyme, and the follicle will still do exactly what it was always going to do. That one strand in the mirror isn't decay. It's a record. A quiet little conversation your own body has been having with time, one follicle at a time, long before you ever thought to ask why.